So, welcome. I'm gonna start the stream now, basically. While I was setting up here, collecting all the stuff, I thought it might be nice to have a little C64 demo running. This one is from this Halloween, actually. This is a Halloween demo by a couple of groups that made basically one huge demo called All Hallows Eve. The group is called The Pumpkins. Well, actually there are many different groups that work together, but for this occasion they call themselves The Pumpkins. And yeah, I like the demo quite much. It comes on 4 discs, pretty impressive stuff. And it's running off the C64 that I just refurbished. And yeah, but that's that, I would say. Let's switch that off. So I'm gonna pull the plug on the C64, put it aside, because the C64 is not tonight's topic. Tonight's topic is the first in probably quite a few episodes on building a CGA replica. The CGA is IBM's first color graphics card for the personal computer, the PC. I don't own one. I do have an EGA compatible card somewhere. Haven't tried that out yet, actually. CGA cards are pretty rare here in Germany because I think not too many people had an original PC. Let's see if we can get this a little bit more centered. And I also have my fan here. I'm gonna put it right over here because there will be a lot of fumes from the solder and the flux, etc., and I don't want to inhale all of it. Anyway, so it's hard to get an original CGA card. There are probably also still some third-party cards from ATI or something, but even those got very expensive, and I think you don't get any CGA card under 100 euros. And for that price, you can actually build your own, very brand new, and that's of course a lot more fun. It's not cheaper, so the bill of materials for this huge card here is around 120 euros, I would say. You can probably get it a bit cheaper if you search for components and buy a lot of this stuff used or new old stock. But I bought a whole bag of components from Mauser because this basically is built up from almost exclusively TTL chips like 74 series. There are a few components like the Motorola MC6845, that's the video processor or CRT controller, that you have to buy used, and the DRAM has to be old stock basically. Also my ROM chips are old stock, but everything else you can still buy new, which is a nice thing. So I think 100 euros is what you have to spend at least. So it's not a cheap thing. But I thought, okay, once a year I can do such a huge project. And this year's is this thing basically. I have 4 of the PCBs because we ordered in a big pool, and taking 2 was basically the same as taking 1 with a smaller pool. So I've got 2 for me and 2 for Stefan, who just joined. I'm gonna solder 2 of these, 1 for Stefan, 1 for me. Yeah. Today we probably won't be joined by Soul Sister because she's got a flu. I hope I don't catch it. So she sends all her greetings, etc., etc., trying to get back in shape, basically. But one of the next streams she will join us as well and help with the soldering part. Because this is all through hole, it's actually possible for beginners as well. You have to be pretty patient. I'm gonna use sockets, but not for all the chips. For all the modern 74 series that I bought, I won't be using any, but for the old chips I will install sockets for sure. There is also some notes on the backside about the composite output, because the CGA card has both an RGBI output, where there's 2 pins for RGB and 1 for intensity, making 16 colors possible. But there's also a composite out which will output NTSC style video signal, which you can view on modern-ish televisions, or use a capture device like I'm using here from Gubei, which should support the NTSC standard even here in Germany. And then you can do all kinds of neat tricks that has been shown by people like the guys who wrote 8088 miles per hour demo and similar things, or Area 5150, which I think doesn't even use the high color modes. But yeah, you can do a lot of trickery with these cards. And the interesting thing here is that it's basically made up from so many standard regular TTL parts, which also drives the price basically of the BOM. Hello Dana, welcome. So all the DOS Reloaded people are here, that's very nice. I'm gonna open up the bag here, which is really huge this time. I have more stuff down here, like a huge order of new old stock 74 series ICs, because not all of the 74 series are still available easily from Mauser. Some are just are not made anymore, only in the more modern LS variant, or not in the DIP package but in the surface mount package. Yeah, so that's definitely a problem. I think I'm still waiting for the Motorola ICs and for the DRAMs, because series activating. I'm not sure I want that. Yeah, anyway, I'm waiting for the Motorola part and the DRAM, because those come from China, I think. So I have to, in the next days, I have to see if anything is stuck in customs or anything like that. But we got a lot. There's enough to basically begin the project on a meaningful level. And honestly, first I'm gonna pick out this stuff here. These are the bypass capacitors. I have, how many are these? 144. There are 72 spots for soldering bypass capacitors, and I think that's probably all we're gonna do today. Plus probably the sockets for the obsolete ICs that I have to put in here. And this basically, this comes from a reel for a pick and place machine. Yeah, that's a lot of fun. Okay, let's heat up the iron as usual. Here it comes. Set to 350 degrees. I'm gonna turn on a little bit more light here, over here somewhere, here. So that works. I think the sound should be okay-ish. That's fine. I'm also gonna fetch a couple of sockets. I'm not sure. These are 2, 4, 6, 8, 10, 12, 14, dip 28, dip 40, and 2, 4, 6, 8, dip 16. 16, 28, and 40. So let's have a look. Here is a bunch of dip 16. And this might actually be even a dip 28, yes. And there is the dip 40. Yeah, I think that's more or less fine. Adding sockets to all the chips, of course, is also a bit expensive, depending on which quality or type. You're looking at 20 cents to 80 cents extra, and if you have like 100 ICs, that amounts to a couple of euros again. So it's also quite a bit costly. And since I think all the new old stock ICs that have not been used before should be fine, I'm reluctant to put them into sockets, basically. Okay, the DRAM are even of the nice machined kind, basically. There are advantages and disadvantages to each of those sockets. The machined kind is this one here with the round holes. Will it focus? Does it focus down here? Do I have to tap somewhere? No, it doesn't. No, it does. Okay, so they look like this, and the other ones are of the dual wipe variety, where there's two leaf contacts basically. I think these one here are just fine. These are supposedly of a bit higher quality, but yeah, I've heard that they also have some disadvantages regarding the legs of the ICs, etc. So here we go. These are all the... I've got one spare. I might have to get some more DIP 16 sockets in the near future, but I might have some leftovers somewhere. Let's see how to center me more properly. I think like that. All right. I do have something to hold PCBs, but this one is definitely too long. That won't fit at all, I think. So no use in trying. And I think this socket here has a slight problem, because yeah, one of the legs was slightly bent. All right. Should probably put some tape on there. 1 second. All right, some masking tape. Yeah, thank you, Stefan. DIP 16. Well, I think I do have more somewhere. You can't see my shelves here, but I bought a couple of boxes from IKEA to get everything sorted. There's a lot of chaos here still, and I definitely need to get things into more of an order here. Come on, don't go out. And there probably will be some sockets somewhere. Okay, this should be pretty quick. I'm gonna try to turn on the fan. If that's too loud, please tell me. I'm gonna try to put it here a bit on the mat so that it hopefully doesn't resonate too much. Oh, it does badly. Yeah, maybe I'm just gonna open the window. Maybe I will just open the window. Because there's usually no cars outside, which is fine. And I can turn this on if it gets too bad. Okay, let's see. I think it's a bit windy outside. So first I will put solder on each corner of the socket so that even if the tape falls off, nothing will happen. And Once we have all the sockets in place, we can start putting in the capacitors for the sockets. Yeah, and I definitely have to check where the Chinese orders are, if they got stuck somewhere, but I think it usually takes a couple of weeks. So yeah, the CRT controller is, I think, the most expensive part. I'm actually interested. I ordered some brackets. Let's have a look where the brackets are. Oh, got some nice boxes. That's very nice. Mauser uses sometimes these very nice boxes for integrated circuits, and they're very useful, especially if you have some old chips that you want to send to someone when you're trading or something. They are very sturdy and they protect against, well, static discharge and stuff. And I'm always very happy if they put the chips in there, because sometimes they just use like this here cut tubes basically, which is fine, but I like the boxes better. And I'm looking for the brackets. Where are the brackets? Because the main problem with these homebrew cards is how do you fasten them in the PC, basically, in the end. Usually cards have these brackets. Oh, I don't find it. Damn it. Do I have to unpack everything? Oh, I think here, I found them. Hi Tobach. Good evening. Welcome. Okay, so I ordered them on a hunch. Basically, I did some measuring and I think they should fit. And I hope they do. So basically, they are with these D-sub 9 cutouts, and I think this might really fit. Yeah, that could very well be the case. Okay, we will see once we have soldered the connector and can attach this with the hex screws here in these holes, and then we will definitely see if it works. The only thing then is we need to drill a hole here in this place for the composite output, but that's simple enough. I can do that. I did that for the Adlib clones, so that's possible. That's definitely good news. This is looking very promising. Okay, let's continue. There's a lot of sockets to be soldered. Yeah. Okay. There was one more over here, yeah. That's the ROM socket. Okay, now I have put everything down. I can remove the masking tape so that it doesn't get stuck, basically. Okay, this looks all flush and neat. Yeah. Looks okay, I think. Stefan says bracket looks good. If not, I can make some from blank ones. Oh, really? Do you have like tools? Because I mean, drilling a hole is not a problem for me, but getting the D-sub cutouts, that's at least for me, it's almost impossible. I know that at work, I think we have like a punch tool for something like that. But I'm not sure how that works, or how it works, or if it's the right size, or if it was a something else, 15 or something. Yeah, and then I looked up how much a tool costs for making your own, and they're like really expensive, like 100 or 200 euros at least if you buy them used. So yeah, tools for punching holes seem to be very expensive. For whatever reason, I'm not sure. Maybe they're made from extra strong metal or have to be made very precisely. I don't know. But I think you can earn good money in building tools. So I think this will take at least, I would say, for me, if I'm not super rushing it, 4 or 5 hours to solder, I would guess, because there's so many solder joints here and sorting of chips, etc. Because, I mean, you have to, there's like 30 different components, 40 different ones. Hi Neonan. Neonan is asking, alone tonight? Yes, unfortunately, because Soul Sister came down with the flu and she's recovering basically. At first she wanted to join later, but now she said she probably just stays in bed and yeah, try to get better. Next time, hopefully I won't be sick and we will be both back. Stefan says, punch tool sounds good. I may be able to mill some. Oh, okay. Yeah, that's something which is very useful if you have access to machinery like that. What I did before for some of the cards was design something in OpenSCAD and then have it 3D printed by one of my colleagues. There's a couple of colleagues who have 3D printers, and yeah, so I use 3D printed brackets, which is fine if you don't have to remove the card all the time. It's you usually don't see it because it's on the back side of the PC, so yeah, it doesn't matter that it's made from plastic. But I think having a metal bracket is always very nice, and it sometimes might be used for grounding purposes as well, so could be useful to have that feature. And of course plastic won't help with that, I would say. So when it comes to populating the composite out, we need to have a look in the repository and also on the card here. Oh, there's a car. Sorry for the noise. As I said, here's some description how to populate it, because there's like an old and new style composite out for the CGA cards. I'm not sure which one is better. I mean, probably gonna do just the default population, no, whatever you call it. You have to set a jumper, and there is some changes probably in the resistors here. There are some resistors that I mentioned. Okay, so that's basically all the stuff that's over here. We will probably have to decide, yeah, well, we can do the ICs first and do the output stage last and read up on that. So I think it's not super important right now. Okay, now I'm soldering the sockets for the DRAM chips. The CGA card comes with how much? 16 kilobytes, I think. Not quite sure, or was it less? Maybe let's look that up. I think the Hercules card has more RAM than the CGA card, if I remember correctly. IBM CGA. Let's have a look. Drink tonight is an alcohol-free Hefeweizen, actually. Okay, here is hardware design. I'm looking at Wikipedia. Or does it have 8 kilobytes? Could be 8 kilobytes. Let's see. RAM. Doesn't even say. Oh no, it's 16 kilobytes. Yeah. Okay, 16 kilobytes. That makes sense. Stefan says, otherwise we could ask i440BX to design some for made from tin sheet. Okay. I think we don't need to manufacture anything because I think the one from Mauser actually worked. I do have a couple of blank ones still that I used for the AdLib card. And yeah, I could drill some holes in there, but as I said, not the DB kind. Actually, I think even the Chinese manufacturers like JLC PCB also start to offering machined parts, 3D printed parts and stuff like that. However, I heard from an acquaintance that there might be problems with accuracy or quality. I haven't tried it out because it's not super cheap, and I don't have enough confidence in my designing and specifications. It's okay if I give an STL file to a friend and then he prints it on his 3D printer, but I'm not sure what will come back if I order it in China or something. Yeah, but I might try. I think that could also be something that could be done locally. Like, as I said, I often like to order from Eisler as well, PCBs, because they do a lot of stuff in Germany. They're quick. They're right across here over the border in the Netherlands. But they are super expensive for large PCBs like this. This would have been prohibitively expensive with them. But having something like more or less local to have small scale stuff machined or manufactured would be nice. I mean, the issue with the brackets is that you also have to like fold them like this bend at the top. Otherwise it would just be like punching holes or machining stuff. I think that should be relatively easy, I guess. And you need only relatively cheap metal, I guess. Usually I think this is some kind of plated or treated steel, I guess. Not even, well, stainless steel, but probably some coating on there. Maybe they use stainless steel, I don't know. But I would guess that computer manufacturers are cheap and they would use just some plated steel sheets. Okay, so I'm down to the last 3 sockets almost. And then we might start with the capacitors, perhaps. This is relatively Zen-like. And there's more cars coming. I wonder why. there's usually not that much traffic in our street. Mild steel with zinc coating. Bending is the easy part. Okay. As I said, I have no idea about the manufacturing. I think bending... well, okay, I probably have too little experience. Is hard to get right if you want to do it manually. If you have a vise, that it's possible, but I usually tend to make it like not straight or a bit too high or too low, or I don't know, stuff like that. I had a bunch of brackets made from a friend, like another father from the kindergarten. He does this kind of replacement parts for old Vespas, so the scooters, the Italian scooters. And he has a lot of tools like that. And I asked him, oh, do you do like sheet metal? He said, yeah. I said, I need some brackets for a retro sound card, the Snarkbacker. And he actually did like 10 or 20, which I distributed in the DOS Reloaded forum. But it was a lot of work. He needed a special CAD model and stuff like that. And yeah, he did it more or less for free. But I think he invested quite a lot of time. So I think that's why if you do custom stuff, it's very expensive. Welding, yeah, I never did welding. The only thing that I do a little bit is soldering. Yeah, and that's it, I would say. Okay, we got the sockets for the main ICs, the main old ICs in. I think we can start just laying down all the capacitors. Tons and tons of capacitors. Yeah, that's gonna be fun. Hello, Fred. Welcome, one of my longest, long time patrons. Hello. You didn't miss much so far. I just installed the sockets for the CGA card. Now it's time for the capacitors. I'm just gonna snip them off one by one and put them in. There's like 72 capacitors in here. Loads and loads of capacitors. Basically, every IC has its own little bypass capacitor. And oh god. I'm not a pick and place machine, that's for sure. I hope the snips here don't give up halfway through. But I have replacement ones because they are so cheap. I destroyed one by cutting too hard a metal. I forgot, it was some cable or something. And there was something harder inside than I thought, or it was thicker. Afterwards it was totally dented. I still kept it because I use it for like when I have stuff that is probably ruining the snips. So I use that then. Okay. So, where do we start? I don't know. Let's start with the sockets that we already installed. Let's hope it doesn't all fall out. Yeah, soldering smaller PCBs is actually a bit nicer because then I can use this holding tool. But we can't, so we have to deal with this like that. Oh god! I installed a socket the wrong way. This DRAM socket. Blimey. Well, we know that, so we will not install the DRAM face down. So that's a nice thing. Everything is super cleanly laid out on the CGA. Everything is pointing up, basically. So, yeah. I'm sorry, Stefan, your card will have one socket in the wrong way. Or you have to take the other card that we're soldering. Depends. You pick it. Let's hope we don't make any other mistakes. With the ICs we will double and triple check, okay? that they're soldered in the right way. Otherwise, we need to do some desoldering. Also, I'm wondering, what are the odds that this thing will work the first time? I think we will manage that it just works. The Snark Barker, I put together 2, and both worked right off the bat. And that's a card that is similar in complexity, I would say. It has less chips for sure, but there's like a lot of capacitors, a lot of resistors, tons of stuff. But nowhere near the amount of ICs that we have here on this board. Alright, now to solder all the capacitors, or at least the first batch. And then we have to cut a lot of legs. Here. Also, I'm still thinking about how to attach this card to one of my monitors. The simplest way, probably also the most interesting way, will probably be to use the composite out. Currently I only have the 486 33 megahertz working in a working state. I will try to run 80-88 miles per hour and area 5150 on that, but it might be way too fast. If that doesn't work, I might just take one of my old 286 boards. I have a very old one, which is basically more or less mostly an IBM AT clone, but it's not an IBM. It's some other brand, I don't know which it also has like hundreds of TTL chips. And hundreds of TTL chips, and it has, I think, a 6 megahertz 286, so it's really slow. That's the slowest PC that I have, or just only the motherboard. I could hook that up to a Gotek drive and a power supply, because I think it even has a integrated floppy controller. I think so, yeah. I don't even need a floppy controller card. And that could possibly perhaps run area 5150 and maybe even the 80-88 miles per hour. But I think the latter one is very specific to the original PC with 4.77 megahertz. So it might not run at all, or it might look crap in a lot of places. But we'll see. That's one of my goals, because those 2 demos, you can't really run in DOSBox. They don't work. I think they crash or look like crap. I tried out area 5150 on my 486 with the Trident 8900, and it doesn't emulate the CGA part well enough. At some points it looks fine, and most of the parts look like crap. You can see that it's doing something and there's animation stuff, but the output looks garbled or weird. So I hope that this card allows me to use demos or run demos like that and have a more correct output, basically. And maybe even we can write some of our own stuff for this, like simple things, not on the scale that they did, but maybe some neat tricks with the composite out and stuff like that, playing around with that. Okay, Stefan says, nearly burned a Paula today because Commodore decided to mount the chips upside down in the A500. Oh, okay. Yeah, that's always unfortunate. I think there are quite a few machines with silk screen errors. I mean, Commodore probably didn't make that an error, but yeah, due to some routing reasons, they put in some chips the other way around. But there's even stuff like silk screen where on some consoles and stuff where, for example, electrolytic capacitors have their polarity the wrong way, and you need to put them in like in reverse. That's pretty evil. But mistakes happen. It's okay if it's documented and you read on the web what it's supposed to be like, but of course, usually I just trust whatever's written on the card. Luckily, there's no electrolytics or anything like that on here. There's a bit left over from a potato chip here. Not what I was expecting. Well, this will get cleaned anyway after soldering, so doesn't matter. Alright, those were only a handful of capacitors. We need to do more. But I think progressing quite nicely. Maybe it will only take like 3 live streams to put this together. Because I think the ICs will be pretty quick. The only thing is, it might be December when the parts from China arrive. Let's see. At least the situation is not as bad as like 1 or 2 years ago when the lockdowns in China were really crazy. Then you could wait like months for your stuff. Yeah. Okay. More bypass capacitors. They were really very liberal with the bypass capacitors here. I've seen cards that totally forgo bypass capacitors. I'm no electrical engineer. I thought that these TTL chips need them, but who knows? Maybe sometimes you don't, because I'm not sure. I think they're used for filtering and to like store a little bit of power when the IC draws more current or something. I don't know. And we need more. We need more. And the soldering iron gets sleepy, which is fine. Let's take one more, then I have all the ones here in the center of the card. Alright. Stream is still looking healthy. That's good. Okay. The capacitors were actually pretty cheap in the end because I bought like over 100 and then they get really cheap. I probably could have bought just a whole reel and never have to buy any bypass capacitors in my life anymore. But the problem is storing all this stuff. I'm glad when I have soldered both cards because the box with all the parts is really huge. Come on. Okay. Once all the capacitors are in place, I think we can put in all the modern ICs from Mauser. I'm still thinking about the new old stock 74 series that I had to order. That was not available new. I'm gonna wait until the next live stream, I think, to decide if I want to put in sockets for those as well, because they came from reputable sources, partly from a vendor in Poland that has a very good reputation, and partly from Kessler Electronics. They deal with, I think they sell a lot to the industry when they do like the custom circuits and stuff like that. And they have a lot of logic chips on, in stock, I think. And I think they are used now less often, maybe for repairing old industry machinery. But I don't think a lot of new designs will be based around 74 series logic. Probably only sometimes, but mostly no. Nowadays you would use, if you need to use 74 series logic like bus drivers or something, probably use SMD variants, not the through-hole kind here. But there's, I guess, a lot of machinery still around from 20, 30, 40 years ago that still gets used and needs to be repaired, and probably some ICs burn out, and I think they sell to those people as well. Yeah, okay. I think I need to do more capacitors. Or next time we can have votes which chip to put in first or something like that. We also have to fetch one of the EPROMs and put the character ROM on there. Easy enough to find on the internet. And I think Matt on the DOS Reloaded forum also said he had a copy, which shouldn't be too hard to integrate here. All right. I'm very proud of myself that I actually picked the right capacitors here, because they always come in different sizes and shapes with the legs here, and I picked the ones that match the footprint. That's great. I think inside they're just SMD capacitors that have legs soldered on, or maybe even welded on, I'm not sure. And then they're dipped in some coating and get their value printed or etched on. I'm not sure. There's a very nice book coming out. I think in the US it might even be out already, but I think in Germany it's coming out this month, by Eric Schlepfer and another guy whose name I forgot. Eric Schlepfer is the guy called Tube Time. He designed the Adlib replica and the Snarkbarker and a lot of other stuff. And they teamed up and cut electronic parts open, like capacitors, resistors, transistors, chips, and they show the insides. The book is called Open Circuits. I think I pre-ordered it at my local bookstore, but they didn't call me yet, so I think it's not out here yet. But I'm definitely gonna buy it because it's super interesting. And I remember Eric posting a picture of a cut in half capacitor like these here, and it was basically just an SMD capacitor with legs attached. And I thought, wow, that's pretty neat, and it totally makes sense. SMD is like what the bulk of capacitors nowadays will be sold in, and it's probably more difficult and more expensive to run a production process for through-hole capacitors, and it's much easier to just solder on some legs and make it through-hole that way. So I find it totally clever and sensible to do. Is the stream still good? Because I got a dip here in my graph. I'm always a bit worried that the connection is not good, but it says green and everything good. Well, Metalliferous says all fine. Hello and welcome, and thank you for joining. Soldering iron goes to sleep, which is fine. This will take a little bit longer here to put in. Okay, now we have blood. I poked my thumb while trying to get the capacitor in place. Look at that. And there is one C14 is placed in a very weird place between multiple chips. Ouch, that's really terrible. Yeah, if you joined late, we're putting together here the replica CGA card. That is the IBM color graphics adapter. One of the two graphics cards that IBM shipped with their original PC that came out in 1981. The first card was the MDA, the monochrome display adapter, which was based around the same chip, the Motorola 6845. But I have to put something on there. Excuse me for a second, my thumb is still bleeding. Ja, ja. Genau. And we're back. This gets not safe for work. The stream. CEST says hello, but she's still feeling sick, so next time we will see her again. Yeah. The capacitors are pretty pointy things. And I'm bending the legs a little bit. I know there are different techniques. You can glue them down a little bit with masking tape, but that's also a lot of work. So I'm just bending the legs a little bit. And that's that. That's good enough for me. All right. Here comes the next round. Okay. Beep. The beep is always when the iron has reached its temperature again. I hope I won't be sick next week. Because that would also suck. Problem was that one of our colleagues came into office sick. Not COVID or something, but some regular virus. And yeah, probably got us ill as well. That's why I think you should stay home when you're sick. If it's possible, you can still work from home, but please don't come into office and get the others sick. Because then everybody gets sick. And that is not good. Especially after like 2 years of home office, at least for those people where you can do that, where you don't have to go to a factory or something where you have to produce stuff, bakery or whatever you work at. Okay, I see there's already nice things happening in the chat. Awesome. Sickbay is like 10 meters this way. And also yeah, I hope I don't cut any more limbs off or poke myself in the eye or something. What's the time? 10 past. I will do probably another half hour. So my goal is always to do like 1.5 hour streams. Not do too much. Maybe we will put in some ICs already today. Because doing all the capacitors only is a bit annoying. And I've put in the bypass capacitors now for this whole block. Maybe we can populate this. See if we have all the chips here already. Yeah, I will do this bunch here still. That should take me another 5 minutes or something. But then we can put in some ICs and have the board look nice. The other thing that I could do to attach this to a computer is actually to check and see if there's an adapter for Commodore monitors. I do have two Commodore, so one 1084S and one Philips CM8833. Both accept RGB, and probably this here is 15 kilohertz, just like the Commodore stuff. But I think it doesn't do RGBI, but there might be, I do have one of those simple TTL converters that converts to like VGA level, but that might be too low actually. The VGA I could put into the OSSC, that's one possibility, but I have to look up if there's something where it can put RGBI into one of the Commodore monitors. I would think that must be possible, at least via some simple adapter maybe, because the intensity is just applied to the RGB signal, so there must be some simple circuit using a transistor or something to mix those. I guess that has been done many times before. Oh no, the band-aid is sticky and now the capacitors are sticking to my thumb basically. That's great. One more problem. Yeah. Okay, how many capacitors do we have? Did someone count? I know it's 72 on the whole board. But I didn't go in numerical order because they are like labeled C69, C70, etc. I would say we have around half of them populated now, I guess. I do still have also parts for building my own XT, which would fit this graphics card very well, but only like the chipset and the CPU. There is this Micro 8088 by Sergey Malinov. Hello Angular Momentum, welcome! For all who join late, we are building a replica of the IBM CGA color graphics card. And it's basically a graveyard for TTL chips and capacitors. And as I was saying, I do plan at some point on building the Malinov XT clone. And it would be very fitting to use the CGA card in there. However, that's also an expensive project. Luckily, I bought the chipset when it was still very unpopular. The new XT project made it very popular, and then the chips prices skyrocketed, and I'm not even sure you can still buy them or if they bought all the new old stock. And I do have 2 or 3 chips left that I bought for really cheap, like really cheap, 10 euros a piece. And last I looked, they were going for 60 or even more euros per piece. So I already sold one off on the DOS Reloaded forum for someone who was building that PC and was missing the chip. But I'm not gonna sell off more because I first want to build my own XT clone. And then if I have anything over, I can give it away in the community or something. But right now I first do this, next year maybe the XT board, because as I said, these are all relatively expensive projects. I mean, still not super expensive, but they are all in the order of like 100 euros due to the pieces and everything. You have to do the PCBs, you have to buy a lot of chips and stuff. And I don't do like these kinds of projects every month. That's just way too much for hobby. Because even with my newfound fame due to the HDD clicker video, it's still like YouTube is bringing in like 20 euros a month or something, and Patreon is currently at like 11 euros a month. So from these videos I get something like 35 tops per month, let's say, and that's what I spend then on projects like these, plus a bit on games or other stuff that I just play and don't show off in the videos. Things like that. Probably every one of you have heard of the HD clicker. It's not my invention. Matze on the DOS Reloaded forum designed that thing, as far as I know. There was one guy now who published basically the same project 1 year ago, but I think no one saw it, funny enough. But this year everybody saw it suddenly. Not sure why. And it got featured in Hackaday, and then because I made a video about that, that video took off. It's already my second or even now most watched video, not sure. Hi Ian Scott. Ian Scott joined of Picogus fame, which I'm also gonna solder in the next couple of weeks because he sent me one board, but that's still en route to me. But I got the parts here. I've got a Pi Pico over there, and I've got the DAC board that I need for the sound output. And he says, looks like there's lots of soldering on this CGA card. Yeah, you better believe it. It's it's worthy of the name TTL Graveyard. I'm looking forward to it. Yeah, I'm also looking forward to the Picogus. Definitely. Amazing project that sparked also interest in a lot of other people, like Oscar Toledo, Freddy Vettele, who is designing another board around the Pi Pico ESA interface. So there's definitely some inspiration going on here in the scene. And I think that's a good thing, because the Pi Pico is a great device. I haven't used it a lot. I just played around with it at the very beginning when it came out and did the usual LED thingy with it. But it got this very powerful state machine for driving, for example, the bus. That's really good. Genny D, hello, another fellow DOS Reloaded person. So very DOS Reloaded affinity here on the live stream. Yeah, anyway, I don't know what I was talking about before, but yeah. Either way, welcome everyone. I would say we are like maybe 20% through with this. I'm gonna solder a bunch of chips next because I don't want to do capacitors all evening. And yeah, I think we will need at least 2 more live streams. It depends on how quick we work, but we don't want to hurry it. I already put in one dip socket the wrong way, but because everything is facing to the top, basically, we know that, and we won't put in the DRAM in the wrong way, or otherwise Stefan will be very sad that his CGA card is not working. Because I'm gonna say this will be Stefan's CGA card, so he can watch how we assemble it. Stefan says, the good thing of this TTL graveyards is you can understand what the chip's really doing. With one big custom chip you don't get the same understanding. That's true. The big chips are of course some kind of black box. I mean, I do totally understand it's totally economically and ecologically more feasible to concentrate everything to one chip. But these things can teach you a lot about like computing. How does stuff work? How do video signals get generated and stuff like that? I can take my oscilloscope and probe every little pin and follow everything from the bus through the DRAM, through the bus drivers over here to the video section and everything. I mean, the CRT controller has a lot of magic in there, but it's documented. You can download the data sheet and have a look at it. The ROM just contains characters, so there's no program code or something. Only thing that you would need to look at is perhaps the BIOS code that initializes the card and stuff like that. Okay, let's have a look. So there is, we have to very carefully look because there's variants of the 74 chips on here that are LS, and there are S variants. They have different speeds and properties. They do the same thing from a logic perspective, but they are slightly different in their timings and things like that. So I'm gonna try and find the 74LS00, which I guess should be somewhere in here from Mauser. I also have the LS02. Is it somewhere here? Yeah, we can use the LS02 and solder that. And maybe we find the 00 as well. And I should have sorted them earlier, I guess. 174, 153. Next time we're gonna sort them. LS10, LS00 here. That will be our chips for today, I guess. Let's confirm. There's an LS00, there's an LS00, and we have 6, so there should be one more. Question is where, and I do have the bomb here, which is good. Ian asks, are all of the components for this board except the CRTC available now? New. Yeah, I mentioned this earlier. A lot of them are. Most of them are actually. The CRT controller isn't. The ROM that I'm gonna use isn't, because I'm gonna use one of the UV erasable ROMs. There might be someone still making 27-256s. I'm not sure. Could be. Maybe as a one-time erasable, a one-time programmable. But even if they're currently so expensive that I just bought a cheapish one on eBay, basically erased. I've used those before and they're usually totally fine. The DRAM is of course not available. So this is old stuff, maybe not even new old stock, but that's the case with this old DRAM, but they're usually pretty reliable, sometimes even new old stock. And there are a few chips that are bought from Kessler, as I said, or eBay sources that are perhaps new old stock, and Mauser only either doesn't have them at the moment and they have some lead time of 2, 3, 4 months, or they only have more modern, faster versions, or even only SMD versions. because not all 74 series are still manufactured by TI, and you don't even get any third party. Like back in the day, you would get Synetics or whatever branded 74 series logic, and that's not the case anymore. Texas Instruments is the only one who does that anymore. Let's have a look here. I'm looking for the LS00, and that's U15. U15, okay. U46 and U25 are these, and U15 is somewhere up here. Okay, good. So let's do the LS00 first. Stefan says, does someone know a CGI creator? It would be awesome to do an animation how the bits become pixels in this adapter. Oh wow, yeah, that would be probably pretty difficult to animate, I guess. I wonder how you would do that. I don't even know how that works. Question is, does it even make sense to visualize it, sort of? Because everything's happening like in a couple of 100 kilohertz or megahertz space, especially with video signals. Maybe. I think it would be very hard to do an animation of this. Okay, here are our first logic chips. I have to bend them a little so that they fit. Make sure that they're facing to the top with a little notch at the top. So this is an LS00. Let's double check. Can you see that? Perhaps. Something like this, I think you could see it. 74 LS, and the notch is at the top. And in goes the next one. It's over here, U25. And the last one was up here, U46. And we didn't even put in the bypass capacitor, but that will be no problem. There's a lot of space. I can reach it relatively easily. U46. Okay, I bent the legs on the other ones so that they don't fall out, but this one does want to fall out, yeah. That's probably not the cleverest thing I did, but I will bend the first two legs a little bit so it doesn't fall out. Okay. Neonam says, have you ever experienced with wavefront OBJ format? I coded some parser renderer of a model in this format, but have troubles with visible hidden faces detection removal. Oh boy. Let's wait for the truck or the tractor probably to pass by. And that was probably some farmer. Yes, I do have experience a long time ago, like 15 years now, because most of you probably don't know, but I do have a PhD in computer science, and I did that in computer graphics actually. I do work in a completely different field now, and it's a long time ago, but few of my colleagues back then at the university, they did a lot of research about stuff like that, and it's actually pretty difficult to get proper 3D models that are watertight or have specific properties, and you can do a lot of research there. So it's actually not an easy task. All the modern 3D software like Blender or the commercial ones, they have very powerful tools now for mesh processing. There's also a lot of algorithms that repair 3D models and stuff like that. But the thing is, you can always input a lot of garbage into these algorithms, and it's very hard for them to fix everything. Yeah. Ian says, I 3D printed a dip leg straightener, but I usually just push the pins against the table to straighten them anyway. Exactly. I do have this tool here for the resistors, and I think it's very useful. But I always use the table for straightening out the chips. All right. Here goes the second chip. No, come on. Okay. All right. So for example, if you know the tool OpenSCAD, they use a library for computing the meshes, the final meshes. I think, I forget the name, but we used that library back then as well sometimes. And it's specifically designed because it has like arbitrary precision arithmetics. Because if you don't do arbitrary precision, there will be rounding errors and you will get gaps between the triangles and stuff like that, which of course totally sucks if you try to produce something watertight by printing or something. And it can lead to weird results. So yeah, putting this into 3D just for animation purposes is probably easy enough. And that shouldn't be too hard. But doing like the simulation, I think you need to use the schematics that come with this project and put it in. I think there are specific tools that can do like logic simulation and stuff like that. There's software for that. I never used it. And that should be possible to simulate that. The question is does it make sense just to show that? I think that would be the same me just probing pins on the chips. You would need a little bit more documentation, I think, because there are probably certain blocks here that serve certain functions. For example, doing the DRAM refresh or something. I'm not sure how that is generated. Probably some signal from the ISA bus or something gets there. Then you have the bus decoders and bus drivers that do something, but also the video output from the chip that gets routed somewhere. I don't know. I guess most of the stuff is anyway support logic, address decoding. I think most of the stuff happens here in the CRT controller, I guess. So I'm not even sure how much of the video magic happens in the TTL logic. I don't know. Okay, this is the 70LS02. It's a quad to input what? It doesn't say. Anybody know what the 74OS02 does? Would be nice if they told us on the package. Let's have a look. Is there a list on the web? 74 Serious Logic there. So 7400, what we had just now, is the quad NAND gates, and the 7402 is the quad to input NOR gate. So we have NAND and NOR. Okay, no idea what they're for, but yeah. Neonam says, I actually don't need to create working tool for process OBJ files. Blender open it fine and beautiful. Yeah, as I said, it is in educational purposes, like you showed VGA coding for Hex 13 mode. Make my own 3D renderer. Ah, okay, yeah. That makes sense. writing your own 3D engine is always a good thing to do. I think back in the 90s, the demo scene was basically first task, write your own 3D engine. That has gone a little bit away, I would say. I think no one codes their 3D engine from scratch anymore, at least not on modern PCs. Because that is all done by the graphics hardware and Windows and Linux and macOS, etc. But it's, again, it's very educational to write your own 3D engine. Then you understand how all the algorithms work, how a graphics card works, etc. I was very proud when I learned about rotation matrices in like 12th grade, 11th grade, I'm not sure. And then I coded like my first star field. Okay, getting distracted here. Let's check 74LS02 is U65 and U49. U49 is this, and U65 is somewhere over here. 74LS02. Yeah, that's looking good. Double check. This should be U65, that's the case, and the notch is at the top, and the other one is down here, that's U49, and also notches at the top. And right at this time it goes to sleep. All right. The second one around here. Okay. That's that. Okay, let's grab another bag of chips basically and see what we find. There are two more here. Oh yeah, come on, this will be our last thing, I guess. Those are 74 LS74s. The L7474 is. Let's take a look. What does it say here? Oh, they're flip-flops. Okay, they're dual flip-flops. That's fine. Metallifer says, on 3D engines, I can recommend the game engine Black Book, Wolfenstein. It has some great explanations on how they made the game, what hardware they had to work with, etc. Okay. I don't know it. If you have a link, please paste it if you're allowed to, or if there's an ISBN number so we can search for it. That would be nice. These are 8, so I need to have 4. Stefan says, sounds simply amazing for someone who didn't go much further than Hello World in C. The black books are awesome. I think the one book, I don't have it. I don't have that book, but I know I do have the PDF. And I know that it was the book to have for DOS graphics programming. Was by Michael Abrish or something. He was the guy who described Mode X, etc. I think that was the book to have if you want to have the basics for the hardware, not like 3D engines, but just regular graphics. 74 LS74. Where do we have it? On the back. So we do have two different ones. We do have the 74 LS74 and the 74 S74. Okay, now I have to look it up. It might be that the 74 S74 can be replaced with the LS74, but maybe not. There were 2 or 3 chips that could be replaced with the LS variant. CGA Redux on GitHub. There we go. I'm looking it up. So 74. Okay, it doesn't say anything about that. Whoops. Closed my window. Give me 1 second. Okay, the author is saying the 174 can be replaced with the LS174. He also used slower DRAMs, which was fine. And the 74153 can be replaced with the 74LS153. Most probably. We might want to put in sockets for those. And the DRAMs, yeah, which kind of DRAMs you can use. Okay, I might have the S variant in here as well. So I'm gonna put back 2 of the LS kind, because I'm not sure if these are actually compatible. I think I might have ordered the S variant from eBay, because I'm pretty sure I went through the BOM multiple times to check out that everything is really compatible. So the 74 LS74 is U2 and U11. U2 should be up here. Yeah, that's the case. It says 74 LS74. So we're going to use that. Otherwise, we can put in sockets for the for the 74S variant if I didn't order. But I think I have to go through the box, but we're probably not going to do that today. And U11. U11 is over here, 74 LS74. That's correct. Come on. If they're getting in at an angle, you don't get them in at all. I think the legs are not straight enough. Yeah, now it's fitting. So, as I said, U2 is over here with the notch at the top, and U11 is over here, and both are 74 LS74. That should be fine. Turning it over, heating up the iron again. Putting down a leg on each side so it doesn't fall out. And here we go. I might use some black pen next time to just write it very large on all the boxes, or I need to get some kind of ordering system. Maybe we just put them here or there on a table or something, sorted by number, because this is really really crazy and nuts to get sorted. And I only soldered like 2, 3, 4, 5, 6 ICs. It takes ages. That really takes ages. I'm gonna have a very quick look before ending the stream in the box if I have the, and I'll leave the 74LS out here. If I do have the S variant here, might very well be the case. So this one is the LS374, which was not available at Moses. This is the 244, which is actually a pretty common chip, but I think that was sold out at Mauser. They are all Motorola brand, so they are probably already quite a bit old, but they are completely new old stock. They look totally fresh. The 374, which we didn't see before, another 374. I think there is quite a bunch of those on here, or it might have been cheaper to buy them in like this package size, or not even possible to buy it differently. Okay, what do we have here? This is an interesting package. I think this one is the one that came from Tesla Electronics. So here we have, what is this? It's tiny, I can't read that. That's the 74 125. This is 166. And this here is 245. 04, 7404, and this here is 273. All right. Any other? Oh, look over here. There we have something. That's the 112. And what's this? 244. Okay, I've got a bunch of 244s, but there's already a couple of them here, I think. Well, let's see. Okay, I think that's it with the new old stock things. Ugh. This is a mess. Okay, I don't see the 74S74. I have to look up in the thread what if I did write anything down about that, because I'm pretty sure I checked everything and chose only compatible parts, but I don't want to solder down the 74 LS74 in place of the 74S74 if I'm not 100% sure that they are compatible. Perhaps I need to check my orders if I ordered them in China or somewhere else. Not sure. But we've been streaming now for 1.5 hours with content. That's where I usually draw my limit. Are there any other questions? Are there ideas, comments? Do you want to see something before we close up the stream in the next 10 minutes or so? Another C64 demo, I don't know, because this won't be running right now, so we can't test it yet. Anything else? I'm very glad that you all joined, for sure. It's always a pleasure having so many people join and chat. Gian Mario says, personally I would have used sockets for all ICs. I hate soldering and hate desoldering even more, and sockets are super cheap. Yeah, I think I said that in the beginning of the stream. I will use, probably for some of the new old stock, I will put in more sockets. For the DRAM, for the EEPROM, for the Motorola, definitely, because I cannot be sure that they work super reliably, or if I have to reflash the EEPROM. The brand new ICs, I think that's a waste, because I won't be tearing down this thing, and yeah, I think there's no sense in putting in sockets. The cheapest sockets that you get are usually like 15 cents at least. If you buy better ones like the machine ones, they can get really expensive. And if you have like 80 ICs on you're talking. Okay, Siri just activated again. If you have 80 ICs or something, you can spend like 20 euros at least on sockets alone, and then that's already like almost 20% of the whole bill of materials. So I'm leaving it out for most of the ICs. I do have the TL866. I can use it to try and test the new old stock chips, but it won't detect all failures, obviously. Gianmario says 20 euro well spent. It depends. I think that's totally down to your preferences. If you want to spend that, that's fine. I think I personally wouldn't, because these will be fine. These are new Texas Instruments chips. I haven't had a failure on these ever so far, and I built the Stark Barker, for example, without sockets on these chips. Jason Adventure says, I enjoyed the stream, but I think I need to leave a note about the turned pin sockets because it stressed me. If anyone else builds one of these, try and use leaf sockets, it'll be more reliable. That's what I said in the beginning of the stream. You probably joined later. I said that there's very different opinions about the machine sockets. There are people who say, oh, they are the best, but I also heard, I didn't have bad experience so far, but I don't have a lot of experience anyway with all this stuff. I heard a lot of people say that the leaf switch sockets are better, which is why these are new from Mauser, these sockets here. I only buy the dual wipe sockets and use them. The machine sockets, I got like a whole bunch for very cheap off of the forum, and I put them in here because those are the DIP 16 sockets that I currently have, and I think they will be working fine. But if I were to remove and add chips all the time, I wouldn't use these. Yeah, I would rather use the dual wipe sockets, and usually they are a bit cheaper anyway. And I haven't had problems with dual wipe sockets, at least if they are proper brand and you don't need to replace the chips all the time. Of course, they will wear out and stuff like that, but I have like the Commodore 64 with dual wipe, which are like 35 years old, and they work fine. I mean, Commodore used to build those machines with single wipe sockets that have only one metal piece in there, and they really are bad. I think maybe my pet has single wipe, I'm not sure. I have to check that, because that is actually having some problems, but it's also dirty as hell. So that will be another project that we need to do, clean up the pet and get it running properly without crashes. Yeah, so I would agree with Jason. Don't buy the machine sockets. You don't need them. I just use them because I have them, and I don't think there will be a super big problem here, because they are new and I can even put some deoxy in there or something, and I think they will make good enough contact for the DRAMs to work fine. But no, I wouldn't buy them again. Basically, it's just because I got a whole bunch of them for relatively cheaply, in different sizes, so I use them here and there. Stefan says ZIF sockets would be a little over the top, I guess. And most importantly, ZIF sockets wouldn't fit here because they have a large footprint. It would at most make sense, let's say, for the BIOS chip, it's not even a BIOS, it's the ROM chip with the character ROM, or the controller here. If you want to have a card where you test ROM and Motorola chips, CRT chips basically, CRT controllers, then you could put in ZIF sockets. But even here, it might be like with the bypass capacitor here, it might be too little in the way of place here. You might have to stack two sockets on top of each other. Maybe I could put in a ZIF socket here and then have that. But that would be only if you want to test a lot of these chips. So ZIF sockets are no good except for testing chips. that's where you use them, or if you have to program ROMs or something like that. Yeah. Anyway, looking at this now, next time we definitely need to have a bit more organized layout of the chips, because the searching of the different chip kinds. So next time I will lay them out in numerical order, basically, so we can just grab on the table whatever we need. That should accelerate things. Next time we will also put in the rest of the bypass capacitors. I think we have roughly half of them, maybe a bit more. Let's count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 20, 25. Okay, we have slightly more than half of the bypass capacitors. And we need to put in something like 70 ICs still. Okay, a little bit less because these are just plugged in. And I'm waiting still on the CRT controller, so let's see when that arrives. But that is it, I think. It's almost 10 o'clock in the evening here, and there's work to be done tomorrow, paid work, so I think thank you all for joining. I hope you watch the next Lötstream as well, when we continue building the CGA Redux card, or Redux, whatever. Ian Scott says thank you. Stefan says it should be a joke. I hope we don't need a test board. And John says that is a crazy mode of soldering. Yes, John, it is, but we will manage. It's like 1.5 snark barkers, I would say, if that is a measure for soldering. Metalliferous also said thanks for streaming. So yeah, see you next time, and stay safe, stay healthy, and have a great week. Bye.